Hello everyone. So we'll begin the session in 2 to 3 minutes. Let everyone join. Okay, so there is no any prerequisite for today's class, and anyone can join me today because I'll be discussing about infinity, origin, and about the dimension. Okay, dimensional system. So we'll begin in 2 to 3 minutes. Okay. In my system, it's 2:57. So at 3 we'll start. So okay, let's start. Let me share my screen. Okay, so I hope that my screen is visible to you all, and we will start with the infinity. So first of all, before I write something on the board, first how we see infinity as a mathematician, how we see infinity as non-mathematician. So non-mathematician includes physicist, uh, we have the chemist, or any other experts who are not from mathematics background. So in mathematics, infinity is treated in different way, and if we just consider non-mathematician, then they consider the infinity in different way, because mathematics is actually a tool which is used by physicists also and other experts also. So, but when they explain infinity, they don't take that use of mathematical tools, but they just give their interpretation on infinity. So we will discuss both of the aspects. So first, I'll discuss the non-mathematical aspect because that is a little easier. So first of all, non-mathematical. Okay, I don't have PPT, and this is just in blank pages, and also I don't have a pen tab, so I'm writing just using these available. Okay, so non-mathematician, if I say, how they treat infinity. So first of all, to understand the basic idea of infinity, that how we say infinity. So first of all, infinity is not an absolute term. It is not an absolute term. Okay, so it is not an absolute term. It is purely relative term. What is the difference between absolute and relative? We have had discussed in the special theory of relativity, but still I'll discuss here also. So absolute means when there is no comparison. Okay, when there is no comparison, we say that particular event happened. That's absolute. But when we make a comparison between two or more, then comes the relativity. Okay, so in context of physics mainly, because I take two things, physics and mathematics, so I just combine them. In as physics, in physics we discuss motion. So whether it's rest or uh, dynamic, whether it is static or dynamic, both are the relative terms. Okay, they are not absolute terms. Similarly, infinity, the concept of infinity is also relative. It means that, suppose for an example, if we consider that someone has 1 rupees, okay, and someone has 1 lakh rupees, okay, I'm writing lakh by L, capital L. So here, if we have to understand the concept, if you have to just give the your point of view on infinity, then we will say that 1 lakh is quite bigger than 1 rupees. So itself 1 lakh is countable, but here in this comparison 1 lakh will be called as infinity. So here comes the contradiction, that mainly when people explain infinity, they say that infinity is something which is uncountable. Again, when you are saying it uncountable, you are making it absolute, but infinity is something which is relative. Okay, whether it's in physics or in mathematics, it's a relative term. Okay, at both positions, it's agree that it's relative term. That if you have 1 rupees and if you have 1 lakh rupees, then comparatively, see, if you have 1 rupees and 1 lakh rupees, mathematically you will sum them and you will say that if you have sum of 1 lakh rupees and 1 rupee, so what you will say, that you have like this. Okay, so whether you will say this, okay, or you will say 1 lakh, surely you will say 1 lakh. If we consider 1 lakh and rupees 1, then 1 lakh rupees 1 has no value uh, if we compare with 1 lakh. So here 1 lakh is quite bigger than 1. So here comes the foundation of infinity, that infinity is actually, which is something very big in quantity. It's a very big. So actually we can't count infinity. Infinity is uncountable. Actually, infinity is not a number; it's an idea. Okay. So when, firstly, as I remember, Srinivas Ramanujan has given the concept of infinity. So he stated that infinity is an idea; it's not a number. What we are understanding here, as in taking the example of rupees 1 and rupees 1 lakh, is just to make a foundation to know about what actually infinity is. It is 100% correct that it's a relative term. Okay, what we say it's uncountable, that's a different aspect. Okay, that's different aspect. See, whenever any concept is being framed, okay, initially we take some examples, then finally we make a generalization. So that generalization is saying that infinity is uncountable. But actually, depending on the situation, the definition of infinity is improvised. Okay, so this is one example on the this infinity is relative. Okay, so this is the non-mathematician's aspect of seeing at infinity. Obviously, this is continued by mathematician also, but there is very much more from what it is. Okay, algebra of infinity. Okay, that we'll also discuss today. So let's discuss. So mathematician aspect. Mathematician's aspect. Okay, like this short form. So mathematician's aspect, if we consider, okay. So what's it? We say infinity can be defined. First of all, it's uh, wrong. So let me correct it. So infinity can be defined in several ways. Okay, this is correct. That infinity is something which is very large, which is very uncountable, and which can't be even plotted on number line. So that's infinity. That's true. That's not the conflict here. But what's actually makes this infinity unique? First of all, you look at infinity. Uh, okay, if we look, it's vertically. Okay, vertically, from this point of view, if you look from this, okay, you are right. So it will look like eight. Yeah. Again, vertically, if we just cut it, there is a symmetry also. Okay, vertical symmetry. Yeah. Horizontally, we can also check. No worries. Let's check horizontally what you can see here. In horizontally also we can see the symmetry, isn't it? Uh, yeah. Because see, I'm drawing here. This is not actually infinity is actually like this. Okay. Since I don't have pen tab, otherwise like this. These whole this if this is forming a circle and this is forming a circle, so both have the same radius. That you have to understand. The infinity looks like this. Okay, so that's the thing. Yeah. So mathematician actually this is the one aspect we see as a mathematician, but there are several more aspects. So let's discuss it. The biggest controversy that I saw, and even I was curious when I was in ninth and 10th standard about infinity, about 1 by 0 and 0 by 0, which is infinity. I got clarity in 11th, and not in 11th actually, in the starting of 12th, when I studied limit, and I got the clarity about whether 1 by 0 is infinity or 0 by 0 is infinity. So there are different, you can say, what you say, types of infinity, or you can say there are different shades of infinity. So what is 1 by 0, what is 0 by 0, we'll discuss, no worries. So first of all, 0 by 0 is not defined. Okay, we can't define 0 by 0. It's not 0 by 0 is equals to 1. It's not the simple algebra that you will say that if I have 5 by 5, I made 1. Okay, if I have 5 by 5, I made 1, so I'll make all with also 0. This is not the case. This is the, you can say, specifically defined. Okay, during the concept of limit, that 0 by 0 is not defined. Okay, whether you say not defined, that is ND, or you say indeterminate form, both mean the same. If something is not been determined, अगर हम किसी चीज को determine नहीं कर सकते, it means that it's not defined. If it is not be able to, if we are not able to determine it, then it's not defined. Means we are not able to define it, then only we are not able to determine it. That's the thing. Now, what about 1 by 0? So, see, we say not defined, okay? But what I feel that it is both not defined and infinity, okay? See, some concepts in mathematics, see, there are two things: explanation and interpretation. Explanation, maybe a single explanation or the near to that will be correct. But when we are interpreting anything, it is quite possible that if someone is saying, if someone's interpretation is saying, we say from A to Z, if it is saying A, and someone is saying Z, which is A is the first alphabet and Z is the last alphabet. So if they are opposite of each other, also quite opposite of each other, if one is at position 1A and one is at 26 Z, then also it's possible that both are correct, because it depends on the situation, it depends on the condition what they took. Okay, so condition is something that matters. So according to me and what I actually understand from 1 by 0, it's not defined as well and it's infinity as well. And from here comes the new definition of infinity, which can be devised from it. Uh, we know infinity is uncountable and about that relative and all. But one more thing, that the statement infinity is an idea, not a number. It also gives us a glimpse that infinity is something which is not defined. Okay, it doesn't mean that 0 by 0 is infinity. No, 0 by 0 is not infinity, it's not defined. Okay, means all undeterminate forms are not infinity. All non you can say all not defined form or all non-definable forms are not infinity. 1 by 0 is the special form which is infinity as well as not defined. Okay, 1 by 0 is the special form which is not defined as well as infinity. It gives us a specific definition of infinity, that infinity can be called not defined when we have something positive, or we say something non-zero in numerator and 0 in the denominator. That's the you can say sophisticated definition here. Okay, while we define the not defining infinity. Okay, so that's the difference between 1 by 0 and the 0 by 0. So with this, I'll be discussing with you the 7 indeterminate form and the explanation why these 7 are called not indeterminate form. What's the reason behind it? Why it is not why we can't determine it? So let's discuss the 7 indeterminate form. Then I'll come to the discussion of origin and all. Okay. So little lengthy this session will be. Yeah. So wait. Yeah. Okay. Let's start. 7 ID forms. ID means indeterminate form. This lecture is something, this lecture is for all those who are making a transition from 10 to 11th also, and also who are confused about these, because this is a very common, you can say, misconception, or you can say confusion between 1 by 0 and 0 by 0, and even the infinity. We are not even aware of infinity. Okay, even I have to make a more discussions on infinity using the algebra of infinity, that what happens when we add infinity, what's the value of infinity plus infinity, what's the value of infinity minus infinity. Okay, so that's the thing. So 7 indeterminate forms. So let me first write and then I'll explain. 0 by 0, then infinity by infinity. Okay, so that's why it was needed to explain the infinity, because here comes the infinity. 0 into infinity. Okay, Then infinity minus infinity. One power infinity. Then infinity power 0. Okay. And then 0 power 0. Okay. So these are the seven. It's seven or not? Yeah. 3 to 5 to 7. Okay. These are the seven intermittent forms. So we'll discuss why these seven are not indeterminate form. Okay. So we'll start with 0 by 0. So what actually will be our, you can say, claim for indeterminate form? So that I'm just discussing with you. Whenever there will be a contradiction with, we have two quantities. Okay. Whether we have 0 by 0, we have in numerator we have 0, in denominator we have 0. Infinity by infinity we have numerator with infinity and denominator also with infinity. In 1 power infinity we have the base as 1 and the power as infinity. Okay, so we have two different quantities. The behavior of one, not with respect to other, but behavior of one when we consider something different in the position of the second one. Okay, you'll understand, don't worry. Okay, what's actually it is, how it's undeterminate form. So let's see. First of all, we will discuss about the this 0, which is in numerator, this one. So what this 0 wants this quantity should go to, that's the first question. See, whenever we have 0 in the numerator, okay, you don't have to think this 0 as a numerator. We are discussing 0 as a numerator. Whenever you have 0 as a numerator, it will always desire to take that particular quantity to 0. Whether you take 0 by 5, whether you take 0 by 10, see, whether you take 0 by 5, this will go to 0. This is actually 0, not go to 0. When we are saying it's go to 0, we are tending it to 0. That's the concept of it. But this is not limit, it's absolute value. So 0 by 5 is 0. Okay. 0 by 10 is also 0. So in short, what we can say here, that any number which is non-zero, which is in denominator, provided that 0 is in numerator, that quantity will be equals to 0. Okay, that's fine. So this particular numerator wants that the quantity should go to 0. Okay. Second one, what this denominator wants, this denominator, this 0 in a denominator wants that this quantity should go to either infinity or we say not defined, because whatever number you take, whether you take in numerator 5 or 10, any number, whether you take 5 by 0, you take 7 by 0, or any non-zero quantity in the numerator, provided that 0 is in denominator, that quantity will go to infinity or you say not defined here. Okay, the special form of infinity which is not defined also. So what's contradiction? If you are focused here, then you must have seen here, but still I am discussing with you, giving you the full explanation. So the denominator which is in numerator, okay, it is making it wants, not it is making, it wants that this particular quantity should go to 0, but the 0 in the denominator wants that this particular quantity should go to infinity or not defined. There is a contradiction. One 0 wants it to go to 0 and other one wants it to go to not defined. So since there is contradiction, we mathematicians say that we can't determine this particular value, because it is not sure in its own zeros. These zeros are also betrayal. They are betraying us. They are not giving us the definitive. that 1 0 is saying that this quantity should go to 0, another one is saying that it should go to not it what you say, sorry, infinity, yeah. So that's not clear here. 10 that's in numerator. I'm just concluding this. 10 that's in numerator wants that this should go to infinity. Other one wants that this should go to, sorry, one that's in numerator wants this to go to 0, and then one that's in denominator that wants it to go to infinity. So there is a contradiction. One wants to go to 0 and one wants to go to infinity. So since there is a contradiction, we will say that 0 by 0 is undetermined form. Fine. Let's discuss about infinity by infinity. Okay. So similar argument we will use that I discussed with you in the first undetermined form. The same argument we will take to all the 7, and all the 7 will be explained very, very easily. Okay. This is the very basic of calculus. Okay. What we say limit is a very basic of limit. And this is whenever I saw even uh, most of the times, whenever any teacher explains in this particular limit using the undetermined form, they just make you write this 7 undetermined. They don't explain. You cram and then you just solve using alphabetical rule and all that. But you don't know. That's why most of the people say that mathematics is heavily driven by logics and algorithms and all. It is, but also there is concept. If you will not understand the concept, you will feel it's like an algorithm only that is going like a computer, step 1, step 2, step 3. There is that part also. Abstract mathematics has abstract nature also, logical nature also, algorithmic nature also, but this is also one part which is being ignored by people. Okay. Because mathematics is the subject where I feel there is the least explanation available. In physics there are different interpretations. I will give you interpretation of special theory of relativity in this way, someone will give in another way. But not in mathematics. Mathematics is maximum people who say that they know mathematics. They don't know mathematics. They cram mathematics. Okay? Maybe they don't cram physics, because if they start cramming the physics, then let it go. Okay. So I will accept that they understand physics. But if you are not able to explain these 7 intermittent form, you are not understanding the core, what mathematics is actually, that is not in your hand. You are just cramming it. Okay. And that more than 95% people do. Okay. Leave. Let's discuss infinity by infinity. So this, and now I'll make it fast. Okay. So the infinity which is in numerator, okay, yeah, so infinity which is in numerator wants that this particular quantity should go to infinity, because infinity by 5, infinity by 10, infinity by 100, whatever, if infinity is in numerator, whatever non-zero quantity you will take in the denominator, that will make it to infinity. So this wants it to go to infinity, but the infinity which is in denominator sitting just looking at this above infinity says that whatever you do, you want this to go to infinity. But no, whether you take 5 by infinity, whether you take any non-zero quantity in the numerator, well, any non-zero quantity you take in numerator, okay, and then this infinity will be in denominator, this particular quantity will go to 0. Okay, this will go to 0. So whatever you take 5 by infinity, whether you take 10 by infinity, it's 0. Okay, it's 0. It's not going to 0, it's 0. It's absolute. So this infinity wants this quantity to go to 0 when 1 wants to go to infinity. Hence there is a contradiction. Hence we will say that is not determined. Yeah, undetermined. Okay. That's it. Let's discuss the third one. Infinity minus infinity. Let's discuss. Whatever was the third one. Third one was different. Still we will discuss infinity minus infinity. So again, we'll make the sorry, same, okay, same argument here, that this particular infinity wants this particular quantity should go to infinity. because infinity minus 5, as I discussed with you that concept, 1 rupees and 1 lakh rupees, we will say 1 lakh as infinity. So that's the thing. Whether you take any non-zero quantity here, okay, in this position, infinity minus 5, infinity minus 10, infinity minus 100, whatever you take, that will be infinity only. Again, this particular infinity, this particular one, wants this particular quantity should go to minus infinity. So one infinity wants it to go to infinity, another one wants to go to it to minus infinity. So these are there's a big contradiction here, because minus infinity is the extreme left end of number line, and infinity is an extreme right end of number line. There is a contradiction, hence it is undetermined. Yeah. So that's the thing here. So actually, see one thing. We say the serious discussion. We say infinity is very large. Okay. Minus infinity is itself very large in magnitude. Okay. If you consider the magnitude of minus infinity, it's infinity. It's very large. But you can't say here that this is determined because infinity is very large, minus infinity is also very large. So then according to you, what will happen? Infinity will be equal to minus infinity. Yeah. If you will say that it is determined, it means that these two quantities should be equal. That's the definition of determined form. That these should quantity will be equal. Then what you are saying? Indirectly you are saying that when we will add infinity twice, or you say infinity plus infinity, this will go to 0, and this is never. This is never. Infinity plus infinity is determined. Remember, infinity plus c, any other form that you are getting out, just excluding these 7, are all determined form. Don't make a special mathematics by saying that infinity plus infinity is also not. No, there is a reason. This particular infinity wants this particular quantity to go to infinity plus infinity, and this particular quantity also wants this particular quantity. This particular infinity also wants this particular quantity to go to plus infinity. There is no contradiction. Both wants it to go to plus infinity, so it will go to plus infinity, and this will be plus infinity. Okay. So actually, when there is no contradiction, then whatever this first quantity is saying, and if it is same, or if it is followed by the second one, then that will be only the value. Then infinity plus infinity is infinity only. Again, I'll discuss with you this 4 more undetermined form, but before that, let's take some more discussions on infinity. Infinity into infinity, what's it? See, first one also wants this to go to infinity, second one also wants it to go to infinity, because infinity into 5 is infinity, 1 into infinity or 8 into infinity also infinity, so it will go to infinity. There is no any called infinity square. Okay, don't get confused. There is not something infinity square. Okay, this is not the entity. Infinity square means very big quantity and you are squaring it. It will be very big quantity, infinity only. Okay. In starting, it is little difficult to digest, but with the more experience, you'll be able to digest. Okay, don't worry. That's fine. Okay, next one. 0 into infinity. Okay. This first quantity, that is 0, wants this particular quantity to go to 0. Yeah. 0 into 5 is 0, 0 into 10 is 0, 0 into 20 is 0. Okay. But the second one, which is infinity, 5 into infinity, infinity, 10 into infinity, infinity. Because that's the comparison. That's what I started with. 1 rupees and 1 crore rupees, 1 lakh rupees, whatever you take. So that's the basic idea of infinity. So 5 into infinity is also infinity. 1 into infinity is also infinity. 10 into infinity is also infinity. So this particular 0 wants this to go to 0. This particular infinity wants this to go to infinity. Hence there is contradiction. Hence it is undetermined form. I think it is quite clear to all of you. Okay. Next one we will discuss. This lecture, as I think, it will cross today 1 hour. Maybe. I'm not sure. Let's see. 1 power infinity. Okay, you can explain by yourself also. Now I have made you competent to explain this. That's easy for you, but not for one who crammed it. Okay, 1 power infinity. This one, which is acting as a base. This one, this quantity to go to 1. 1 power 5 is 1. 1 power 0 is also 1. 1 power 8 is also 1. 1 power 1 crore is also 1. Okay, yeah. And what this infinity wants this quantity to go to? 5 power infinity. What's it? Infinity. What does this particular mean? 1 is multiplied infinite, isn't it? 1 into 1 up to infinity, infinite. Okay. So this infinity, what's the role of this infinity? If we write 5 power infinity, suppose, okay, to see the behavior of this particular infinity, because we already discussed the behavior of what? See, of the base only. That's 1. So 1 power 5, 1 power 10, 1 power 11, whatever is there, 1. It will go to 1. Or it's 1. Okay. 5 power infinity. It's what? 5 into 5 into 5 into 5 infinite times. So what it is? Infinity only. 5 is multiplied infinite and that will be infinity only. Okay. But 1 into 1 multiplied by, up to infinity is not infinity. Okay. 5 into 5 into 5 into 5. See, because 1, when you are multiplying 1 twice, thrice, 4 times, 5 times, 6 times, value is not increasing, it's 1 only. But when you are multiplying 5 twice, thrice, or quadrupled, that is 5 into 5 into 5 into 5, so what it will be? 5 into 5, 25, 25 into 5, 125, 125 into 5, 625. So value is increasing. So it is going near to infinity. Okay. So 5 power infinity is actually infinity. So this particular infinity wants this quantity to go to infinity, and this particular one wants this quantity to go to 1. Hence there is contradiction, hence it's an undetermined. Okay, so 5 cleared. Now last 2. That is, I think, 0 power 0 and the infinity power 0. Yeah. So before I discuss this, one more thing, one more confusion here. Infinity power infinity. What's this? It's actually infinity. It's determined form. How? Because it is not, because it is, there is no contradiction here. This infinity wants this quantity to go to infinity. Infinity power 5, infinity, infinity power 10, infinity. This particular infinity, except this is when this is 1. Okay, because when this will be 1, 1 power infinity is not determined. Okay, except when this is 1. See, this is in the way of a interpretation. So when we are explaining or interpreting anything, some assumptions are taken. Okay, there is not something absolute here also. Nothing is absolute. I say nothing is absolute in this world also. What we say truth, what we say lie, that is also not absolute. That is also, everything is relative. Nothing is absolute. Absolute is the point, according to me, what I feel. Absolute is the point where we don't want to, we want to stop discussion. Okay, we don't want to think. We are just surrendering that, yeah, it's, we are not able to think. Now it's absolute. So that's what some concepts of Newton said. So they said time is absolute, but that is clarified by Einstein that, yeah, time is relative actually. So that's the thing. So infinity power infinity is infinity because this infinity also wants this quantity to go to infinity. This also wants this to go to infinity. 5 power infinity, 7 power infinity is infinity only except 1. Okay, greater than 1 you can say. Okay, now let's discuss about 0 power 0. So what this, I'll conclude with this page only. 0 power 0. This 0 wants this quantity to go to 0. 0 power 0, 0 power 5 is 0. 0 into 0 up to 5 times 0. 0 into 0 up to 10 times 0. So 0 power any, if we take 0 and here this power can be any number, can be any non-zero number actually. 0 power 5 is also 0, 0 power 10 is also 0. But fine. What about this 0 which is sitting in the power what this 0 wants. This particular quantity should go to 1. 5 power 0 is 1. 10 power 0 is 1. 100 power 0 is 1. That's this want this to go to 0. This want this go to 1. Hence there is contradiction. Hence it's undetermined form. Okay, great. Last one, infinity power 0. This infinity, which is sitting in the base, which is sitting as a base, this particular quantity should go to infinity, because infinity power 5, infinity into infinity, infinity, infinity into infinity into infinity. So infinity multiplied by 5 times. Tongue twister, it's tongue twister. Infinity multiplied by 5 times. It's infinity only. What this 0 wants, this quantity should go to 1. Because that same desire is for the 0. Okay. So 5 power 0 is also 1, 10 power 0 is also 1. So one quantity, this infinity wants this quantity should go to infinity. This 0 actually wants this quantity should go to 1. Hence there is contradiction. Hence it's undetermined form. Okay. This was the one portion, one topic of this today's lecture, that is wonders of mathematics. Fine. We'll proceed further. You can take and I'll give you 2 to 3 minutes break. Okay. Then I'll again resume the lecture. Okay. So break of 2 to 3 minutes, not more. In my system it's 3:37, so nearly at 3:40 we'll begin again. I'm not stopping my screen to share, okay, because we'll resume with it. So break of 2 minutes. Okay, I'm back. Audible and visible, I think. Hello, hello, hello. Let me check on it. Yeah. So let's continue. We'll discuss now about origin. Okay. So today we will be discussing only about origin in one-dimensional system. Okay. That's a concept which I devised in the morning, today's morning only, while talking to myself. What's origin is, and the definition of origin for the general systems, 2D, 3D, and 4D system. I already discussed with you while discussing the special theory of relativity with the coordinate system and all. We'll discuss about one-dimensional system, and we will discuss about the origin in one-dimensional system. How we can define the origin in one-dimensional system. So there's a little, you can say, we have to assume something, then we can define it. Okay? There is no something that we can't define origin in one-dimensional system. See, whenever I actually never claim that we can't do this, it's impossible. I've never. I will claim that also when I'll see all the possibilities and I'll see that it's not possible actually in the present times. So for the zero dimensional system, I give the statement that to define origin is not possible. Okay, but for one dimensional system, it is possible with some restrictions, with some assumptions, with some explanations. Okay, so let me start. One dimensional system. I think you are aware of one dimensional system, or I give you a little brief on it. One dimensional system uh, is actually when the, in terms of motion, if I say, when there is motion single direction, it can be any direction. It's not actually that x uh, direction is only the one dimensional. Y can also be the one dimensional. Z can also be one dimensional. The simple statement for one dimensional system is the dimension should be one. Means direction should be one. If this direction is there, this one is there, this one is there, any one is possible. Any one is possible. Okay, but it should be only one. Okay, and it should be absolute. It should not be like explained in 2D space, because if this vector and this vector is explained in 2D space, then this will be actually the two-dimensional system, because then we can make the component, then we'll be given with the angle with the x-axis and y-axis. Okay, then we can surely get the or prove it as a two-dimensional system. So I'm not saying that. I'm saying the just the direction without considering the that it is two-dimensional, three-dimensional, because actually two-dimensional we don't have the discussions in two-dimensional system. We have discussion starts from three-dimensional. Mean there is some concepts in two-dimensional, but mainly the better visualization is in three-dimensional. But we are understanding the concept. So one-dimensional system is the system when the direction of in the direction, or we consider the 1D motion when the motion is in single direction. That direction can be any direction. That is one-dimensional system. Great. How can we define origin in it? So for 2D, 3D, 4D system, how we are defining the origin? The point of intersection of coordinate axes. For two-dimensional, we have two coordinate system. So we can say that whether the point where it will intersect, that will be origin. That can be 0, 0, and that can never that can't be 0, 0. That's possible for the when we will consider the concept, or we will shift the origin. If we will shift the 0, 0 point, then the origin will shift. When origin will shift, it will not be 0, 0. It will be different. So that's possible. So actually, that's the general definition is the point of intersection. So that we will also take care here also. Okay. So just have a look on this. Suppose we are considering any direction. Okay. So let's consider this direction. Okay. See, here we are drawing a line. There is a difference between line and line segment, very basic difference. Line goes till infinity, and the one end goes to minus infinity, other one goes to infinity. Okay, and for the line segment, the length is finite. Okay, so we are considering line. We are whenever we draw in 2D space, 3D space, whatever, 1D, we don't show this sign, this arrow, but still we are drawing the line only. We are not drawing line segment, we are drawing line. It will go till infinity. Okay, that's right. Okay, so what we will consider here, we will draw a line parallel to this particular whatever direction. We'll draw a line parallel to it. See, there are two notations of line to show line. Whether you show this way, okay, or you show this way. Dot, 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 and here also dot, dot, dot. It shows that it will go fit. That's okay. So whether sometimes we don't show this dot, but still we consider it a line because sometimes something we consider without seeing also. That's also fine, not something which I'll make a debate on it. That's fine. That I accept. That's also okay. Because if I have to make the debate, then I'll make the debate on the XY system. That how can you say this is X direction? You can say this is Y direction. Who named it? No one named it. This is just you named it. I'll say this direction. The direction which you are saying X, I'll say it Y. In the direction which you are saying Y, that I'll say is Z. So that's my choice. When you are saying two-dimensional system, you will only restrict with this definition that motion will be in two dimension, two direction. Okay, and we will consider a resultant vector. That's only is the two dimension. Rest is on my hand. If I want to consider this as a y direction, I'll consider it's in my hand. Okay, but this is not this is not accepted by our uh, so-called whenever if someone who is watching me and is in 10th stand, please don't do this stupid thing in your exam because they will feel it stupid. So I'm saying that when if you will make a diagram, you will make a linear equation, you will represent a linear equation, you will say that this direction is y, this is x. They will just cut it because something is also there that is called convention. Okay, you are correct. I accept it. You are correct. That this is because I only explained this in this way. That's correct concept. Concept is correct, but there comes a convention. Okay, there comes the convention. Even in the physics, you say that the current originates from the positive terminal and it goes to the negative terminal. This is also convention. You can say it will go from negative to positive. Who is stopping you? No one. But convention. Okay, convention means it. Okay, so something with the convention or something we say rituals. Okay, so some rituals are fixed that we can't change, but yes, it's in our hand whether we believe it or not. But also, whenever you explain any concept to anyone, please try to see that person's level. If that person is not ready to accept you, don't try to convince that person because you are wasting your own energy. Your concept or whatever I am explaining here, to someone who knows the fundamental concept of dimensional system, that person will know. Okay, that person will accept in a second. That person will accept, but not the person that will accept who crammed the one-dimensional, two-dimensional, one-dimensional. See, there is a simple cram here: one-dimensional X system, two-dimensional X Y, three-dimensional X Y Z. If someone is studying four-dimensional X Y Z T, so at four-dimensional they are correct, but one, two, three, they are wrong because they are just considering one. They are considering only X direction, but there are possible several ones. We can't even count it. Number of direction can't be counted. We generally we say X, Y, Z. So whenever I explain one dimensional, I say X, Y, Z. For two dimensional, you can frame X, Y, Y, Z, Z, X. For three dimensional, just adding Z in X, Y, you will get X, Y, Z. In adding X in Y, Z, you will get X, Y, Z. So that's the way. Y, Z, X, whatever. Fine. That's the thing. Let's come to our discussion. How can it be? Yeah. So any direction you can consider. Suppose we are considering this, and I'll consider this first. Okay. And I'll consider a parallel vector, or I'll draw a parallel vector to this particular line. Okay. Line. So this is important for me to give the convention. Otherwise, I may use this. So then mathematically that will be wrong. That will be line segment. So this dot is making me shift. So this we draw a parallel vector. So the concept is or the assumption is that we have to draw a parallel vector. And that is again a one dimension. See, this is also one dimension, this is also one dimension. Just you have to make a photocopy. You have to make a photocopy. When you are ready with your photocopy, just use one concept that is called parallel shifting of vector. This is a fundamental concept in vector where it is said that vectors can be parallelly shifted, but not all vectors. Not all vectors are allowed to be shifted parallelly. Okay, some vectors. See, I can't get here, but according to me, some are flexible vectors, some are rigid vectors. Okay, the rigid vectors are not following this principle, but we are considering flexible vector. Okay, so that's the assumption. So don't discuss with that. Okay, so it's a flexible vector or a movable vector, you can say. Yeah, it's, I think the term is movable and non-movable. Static, dynamic, you say movable vector, non-movable. So this is actually a movable vector. Okay, so we are making it parallel, we are shifting it parallelly. That's fine. Okay, so just shift it parallelly. When you will shift it parallelly, it will coincide with this particular line. Okay, because we are making a photocopy. Remember, we are making a photocopy. It will coincide with this particular line. So coincide. There's a coincidence. When it will coincide, actually what we did to explain the definition of origin, we made a line parallel to that particular line, and now we made the coincidence of both. So there are now two different ones. It's photocopy only, but but both have their own entity. So we made a coincidence. So we made a photocopy. We made a coincidence of it. So what happened? Uh, Two different. Uh, Both are one dimension only. Both are in same dimension, but they are two different entities, and they are made to overlap. Okay. So, and also this is a special type of intersection. Overlap is a special type of intersection where it covers the whole region, where it covers the whole, you can say, not a single point. It is not making a, or it is not just touching at a single point, it is touching at all the points possible. So this is a special type of intersection which is coincidence. Since it is a coincidence, all the points are now the point of intersection. Hence, in the case of one-dimensional motion, we have infinite origin possible. We have infinite origin possible. Because the point of intersection is infinite, and the definition of origin is the intersection of the axes. Whether it is the same or not, different, that doesn't matter. Both are one dimensional, but to explain the definition, we just made the overlapping, and just we said that there are infinite origin possible, and this is also possible. Now you just see here that it's a line. It will go till infinity. We don't know about infinity. What's the length of infinity? Infinity is an idea, not a number. It's not an any length that we say that 1 crore length is infinity. That's a relative term. That I accept that's a relative term, but that's relative when there is a second one possible. When we have 1 rupees, then only we will say 1 lakh as infinity. No? When we have just 1 lakh, then how can we say that it's infinity? It's countable. So that 1 lakh has different forms, isn't it? That's the thing here, that the line is actually of infinite length. Since it's of infinite length, so what we can say, each and every point that is making the coincidence is origin. Since each and every point is making the you can say, since each and every point are overlapping, all are called as origin. So there are infinite origin possible. What actually happened if you consider this point particular as an origin? Suppose, because they're infinite point, this is also valid origin. So from here, line is also taking the birth. From here, in this way, in the left hand side also the line is taking the birth. So the definition of origin is justified. What's origin? It's the birth. If something, if this is, suppose y-axis, this is your x-axis. Okay, so this point is the point of intersection. What happens from this point of intersection? These axes are taking the birth. These axes are taking the birth. These axes are originating. So it is called origin. Why it's called origin? Because it is the point from where the axes are originating. Here also the origination is there from this particular point, this one. In this direction also there is a birth. This direction also there is a birth. So hence, birth you say, or origin or origination you say, whatever you say. So that's possible, and this is a valid origin, and you can explain it with infinite points possible. Okay, so you take 10 points, 20 points, you can explain it because it's a line. When it's a line segment, when you will say that it's a line segment, then I'll say no. And when you are saying line segment, but this is not line segment. Whatever you are drawing in the plane or two-dimensional, three-dimensional, that is not a line segment. In one-dimensional, if you are saying one-dimensional motion, then it's going to infinity. Whenever there is a line, it will go to infinity. It has infinite length. When we will come to the line segment, then the things will be different. Na? Because in line segment, the length is finite. Okay. In the line segment, the length is finite. But when you are drawing the coordinate axis, what you are saying, you are drawing the y-axis in the vertical, x-axis in the horizontal. What's the limit? What's the limit? Whenever you draw, you make an arrow. Here, you make an arrow like this cap. What does this represent? It is going till infinity. That axis is going till infinity. X-axis is also going till infinity. Okay, so it's a line, not a line segment. So that's also the clarification that should be there. Okay, so that's the definition of origin here. Okay, I think it's clear for you, all of you. So we discussed how we can define origin in the one-dimensional system. In zero-dimensional, it's not possible. I am just claiming this on the basis of my existing knowledge and on the basis of the existing science. In zero-dimensional system, we can't provide with origin. Available mathematical tool, available science, and the researches which are going on. There is no any evidence that we can have the definition of origin in zero-dimensional system. Okay, it can be in future. My statement is for this time, for 358 in my system and in my smartphone 352. So that's the time when I'm saying, and it is valid till the new discovery is there, new research is there. At that point, uh, this point is invalid. But till then, this point is valid, and I think that in zero-dimensional system, the definition of origin, whoever will be given, will be great. Okay, because according to me, we can't define origin in zero-dimensional system. We can surely define in one-dimensional in the way I explained you. Maybe there are different way, but I am not aware of it. I am aware of this particular way, this way, using the definition and using the correct way. This I think is the correct way to explain the origin in one-dimensional system that I used. So our today's lecture was on infinity. We discussed infinity. That was on origin. We discussed origin, and that was on dimension. So actually, the part of discussion was this. Okay, one more point is there. Maybe I will leave here, but still I discuss why. One more thing. We discuss one-dimensional system. We discuss two-dimensional system. We discuss three-dimensional system. Why not 2.5 dimensional system? Why not 1.75 dimensional system? What's the reason behind this? The reason is the combo of infinity and this concept that I'm going to discuss with you, and I'm finalizing the lecture with it. Okay. So, why not 1.75? Why not 2.5? Any decimal based dimensional system, why it's not possible? That we discussed. Why not? Let's make the question mark. Why not? Reason is simple. Reason is quite simple. But this quite simple reason will come in your mind when you will study the infinity and the origin at this depth which I made you feel the concept of infinity and the concept of origin in today's lecture. Now, this I can give you the task to explain, but still I am explaining because I made a commitment to explain. Yeah. So, see what actually happens. In two-dimensional system, you have like this, okay? Two-dimensional system. Whatever is the dimension, one dimension, two dimension, three dimension, okay? As I discussed with you, two dimension is one dimension plus one dimension. Three dimension is can be explained different. One dimension plus one dimension plus one dimension. Two dimension plus one dimension. Four dimension minus one dimension. That's a different way. But if we describe 0.5 dimension, just look. You are describing an axis. That is a line that will go to infinity. Okay, you are saying, okay, it will go to infinity. What's the matter? I'll cut it into two halves. That's possible. That's a simple thought that can come in your mind. That if you are saying that this is one dimension, okay, I accepted that this is one dimension. I'll cut it in half. I'll cut it in half and I'll make a half dimension system. Why not? You can't make it because if you will cut it in half, it will be line, and line if it is, then it is going. It has infinite length. So if you are making this infinity, okay, if you are making this infinite length, if this is of infinite length, okay, and you are wondering of the half dimensional system, then you are making it to infinite by 2, infinity by 2. And what's infinity by 2? It's again infinity. So it's again infinity, isn't it? Infinity by 2 is again infinity. So if you are just taking a one dimensional system and you're cutting it in two halves, it is again becoming the line. And if this was of infinity length, suppose you are saying that I have cut it into half, mathematically it will be of infinity by 2 length. Yes. But what's infinity by 2? It's again going to infinity. It's again infinity. Infinity by 2, if you take infinity and you just divide it by 2, again it will be infinity, because I discussed with you now infinity by infinity form. While discussing the infinity by infinity form, I discussed with you that the numerator, the infinity which is in numerator, how it will behave. It will behave in the way that the non-zero quantity are sitting in the denominator, and then that infinity by 5, infinity by 10, all is infinity. So infinity by 2 is also infinity. So again, you were in the path to get half dimensional or 3 by 4 dimensional system, and what you are left with 4 into infinity, you are left with infinity by 4, you are left with infinity by 3 for 1 by 3, 1 by 3D system. So infinity by 3, infinity 3 by 4 into infinity, everything is infinity. Hence, you can say that decimal based dimensional system is not possible, because everything is in front of you. Infinity by 2, you take 3 by 4 into infinity. See, you take 3 by 4 into infinity. You take infinity by 3. Okay, everything is going to infinity. Everything is infinity. Whether it is infinity by 3, whether it is infinity by 4, whether it is infinity by 1000, it is also infinity. Because infinity is very, 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 very large. Even infinity, even if you take denominator, you will take 1 crore, it is also infinity. Okay, if you make 1 crore paths, then also it's infinity. So in short, 1D, if the concept is 1D, 2D, 3D, 4D, 0D, then only these integers, not integer, these whole numbers are only possible. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever will be there. The decimal based dimensional system is not possible. Okay, so that's it for the today's lecture, and I enjoyed it very, very, very much. And while just devising the concept also in the morning, and now explaining you in the evening, in afternoon, evening. Okay, so I enjoyed very much, and I hope you also enjoyed it, and you got to know something new. Okay, and it enhanced your thinking also, and it enhanced your concept of infinity also. So infinity is something which I can't just describe in 30 minutes, 40 minutes. It's something a big, uh, you can say, a journey. So a life is even lesser to explain the infinity. That's the depth of infinity and origin and all. These are the very, very basic concept, and these are very, very high depth concepts. Okay, the more you go deeper, the more deeper it is. Okay, so okay, so That's from my side. And with this, I'm signing off from this video, this lecture, and I hope that you find it helpful. And thank you so much for joining me in this session. Okay, so thank you so much for joining me in this session. In the future, also, in 3 years, 4 years, 5 years, whoever will see this lecture, I'll be very grateful. Okay, and I've explained everything from basic. Anybody can see this. Okay, so the only thing is that I use the language English. So I think the facility is there to dub it into Hindi or other language. If you know Tamil only, you know Bengali only, you can make it. Language is never a barrier. Barrier. Okay. If you will say to me to explain in Hindi the same lecture, I can take again. I can explain in Hindi. But the language which I know English Hindi. So I can explain you in English. I can explain you in Hindi. Language is never the barrier. Language has never been the barrier for the knowledge. For the okay. For the studies, language is never the barrier. Study well, understand the things, understand the real things. Don't understand the dummy things, don't understand the fake things. Don't be in illusion, be in the reality. We are living in the reality, we are living in the beautiful nature, we are living in the beautiful world. We should respect it and we should feel the nature, we should feel it. Infinity is everywhere. I started with the example uh, 1 rupees and 1 lakh. Infinity is everywhere. Mathematics is all everywhere. Physics is everywhere. Chemistry is all everywhere. Biology is everywhere. These are something. Actually, what happens? Now? Everything converges in nature. We have just distinguished, and this is our actually this is our bad manner to distinguish between physics, chemistry, math, and biology. Everything converges in nature. Nature doesn't distinguish between physics or mathematics or chemistry. That's our okay. That's our deed, and we should feel sorry for it. Still, thank you so much for joining me in the session. I'll soon plan or a day I'll have a different thought. I'll plan the new session. Okay, on the different topic. Okay. So bye bye. Take care, and I'm just ending this lecture. Okay. It's already nearly 73 minutes, the highest lecture of on my channel. The highest was, I think, before that was 52 minutes. This is crossing that 73 minutes. Thank you so much. Bye bye. Take care, and I'm ending this stream in 3, 2, 1. Okay. Bye bye.